Good morning, everyone. Am I audible? Okay. So what
Yes.
we have learned till the time is, we have started with what is AI, what is artificial intelligence, right? How it differ from human intelligence, and then we have seen types of learning, classification of learning, basically. So we have seen what is the meaning of supervised learning, how it differ from unsupervised learning, and how one step further we can take machine learning using reinforcement learning. And we have also seen that further it can be classified as four types, like semi supervised, but we have not gone in detail of semi supervised as it was not part of your syllabus, that is part of advanced syllabus, right? But we have seen that if you are getting data which is mixture of label and unlabeled, then we need to put it as semi supervised learning, right? So today we are going to see a well composed, what is the meaning of well composed problem. So you all must have received uh, you all must have received that what we can say syllabus, right? So as Puskar sir has shared with you all, right, go through that, and I would be sharing this VLP code soon, maybe this weekend. Okay, so here if you see, this is what we are going, what is machine learning, type of learning, supervised. So the next problem statement is well posed learning problem, designing a learning system and issues in machine learning. If time permits, we will start with this hypothesis space also. Okay, so let's start without further delay. Okay, so what is this well posed learning problems? So these two definitions are considered to be nice definitions for well posed learning problem, right? So according to Mitchell, what he said, that a computer program is said to be learning from experience with respect to class of task, right? So if you see here, right, so if you see here, what it is saying, that three important parameters you need to know, that a computer program or agent or intelligent program, right? So it is going to have, like uh, it is going to learn from its experience. So three parameter you noted down, that first is experience E, then after it is having some class of task T, and performance measure P. So what it is saying, that say that computer program is basically performing some task or class of task. Why only one task? uh, it could be class of task, right, T, and we are going to measure their performance by P, right? So that performance P, this P, which is the performance of the task, right? So this performance should improve over the experience. So as we have made a program in machine learning, right, and machine is started learning. So after some time, when there would be a more experience, at that time this performance P should increase. So this performance should increase over the time. So this is important to understand, right? So if it is happening, in that case, what we can say, that this is well posed learning problem. And a very nice example of this is self-driving car or autonomous car. So if the car is autonomous, right, so many thing computer as reinforcement learning is most of machine learning algorithm for various tasks in self-driving car, right? So it started identifying that what if animal is coming across the vehicle. This doesn't happen much in abroad, but still, what if there is a sudden turn, right? What if it's raining cats and dogs? So what happened here, that this experience with experience, the performance measure should improve. And the second definition, which is way older than this one, this is with Harvard. So what it says, that a machine learning problem can be considered as well posed if a solution exists to it, and that solution should be unique, and if that solution depends upon data or experience, but it is not this is important to understand, that this is not sensitive to small change in data and experience. What does it mean? That, for example, we take the simplest of the example, that weight and height issue, right? So multiple say that samples are there, and there would be outliers also. Consider, someone, this is weight, this is height, someone whose weight is very someone is heavyweight person, but his height is not that great. Similarly, someone is very heighted, tall and slim, right? So it can be like this. So this could be outliers. So what it is saying, that if two three other samples we added, say that one sample come this side or this side, right? So these addition or reasonably small changes should not affect my function, right? So this is important to understand, that if my changes is small, it should not change experience drastically. So is this fine? Everyone understood this? Shall we go ahead, or do you have any query?
Yeah, it's okay.
Okay, so now let's see, what is important to have a well-defined problem. So these three features need to be identified. So the first thing is the classes of task, right? We are going to find, because we are talking about that, a computer program which is going to perform the classes of tasks. So in well defined problem, we need to identify classes of task. Then we have to measure the performance, which can be improved, which should be improved over the time. And the third thing is source of experience, how it will learn, so that this performance can be improved. That learning should be continuous, and then only we can talk about the performance can be improved. Okay, so let's go with a few examples which are very, popular applications of machine learning. Handwriting recognition learning problems, right? And it finds many OCR application also. You must have heard optical character recognition applications. So if it is a handwriting recognition learning application, so we are going to look now, that what would be task in that case, what would be learning experience, and how performance can be measured there. So task T could be, recognizing or classifying the handwritten words. So for example, this is it, this could be also it, this could be also it, or this could be also it, right? Similarly, one someone write like this, one someone write like this, one someone write like this. So recognizing and classifying handwritten words. So I'm just talking here about digits. Similarly, someone write like a like this, a like this, right? So everyone write differently, isn't it? So the task here is recognizing and classifying them. uh, right, so here this is a classification problem. Now coming to the performance, how you're going to measure the performance. So it is going to be kind of, percentage, how much percentage we have identifies those words correctly, so that we can put it as performance measure. Or training experience E. So what would be this experience E? So you must have some sort of database, right, where all these handwritten words are written, everything, right? So you need to have a database where all these varieties are already put, right? So different types of different person write it differently, so all these variations or maximum variations, we can say it's not possible to put everything in training data, but what we can ensure that maximum variation is present in that database. So a database of handwritten words with a given classification means what? How much output would be there? So if it is just digit recognition here, if we are talking about digit recognition, then only 10 classes are sufficient as output, and that those classes will vary from 0 to 9, right? Whereas if it is character recognition, then depends whether only caps letter are allowed or both letter are allowed. So if it is only caps letter along with digit, so 26 plus 10 would be the number of classes. If it is small and capital, then it is going to be 26 plus 26 plus 10. These many classes would be there. Like this, complexity will increase. So this is all about handwritten recognition learning problem. So you must be understanding now that any problem statement which we want to solve it through machine learning, it's important to identify the task. It's important to identify how we are going to measure the performance, right? How we would be measuring it, and we need to ensure that it is getting better over the time. And then we need to also find that what would be training experience. Okay, is there any query?
No.
Okay, if not, someone please quickly let me know that if it is you know a robot which is learning driving, for which what would be task, what would be experience, and what would be the performance for this problem statement? Any one of you? Even if it is not correct, that's fine, but at least you try. That if this is a given problem, then what would be the experience, what would be performance, and what would be task? Okay, task would be, driving a car on a 2-lane, 4-lane highway, right? Why I'm saying highway? Because many algorithms fails when you are trying to when you are trying to make learn this robot in city, right? So many things are there, then that's why in highway it could be 2-lane or 4-lane, so how lane changing happens and all, so that could be the task. Performance measure, so how much distance we have traveled, how much distance that robot has traveled without error, without wherever brake should be applied, was it applied, accelerator was applied at proper time or not. So all these things, right, as a human overseer, so we need to see that without making any error, whenever some obstacle come, it could be suddenly also, or something is passing, so how this robot has how this robot has behaved that time, right? So that is what is performance measure P. And then after training experience E, and that is basically sequence of images which are, like, if we are talking about car driving by a robot, in that case multiple sensors would be there. Camera sensor I'm talking, many would be front side, rear side, then after side views, for side views, right? So what would be experience, what would be your input data, that will be the experience, right? So a sequence of images and various command, what for a particular situation need to be done, those would be the commands, right? uh, so that is the training experience. Are you getting it, that how a problem statement um, need to be break down as task, performance, and experiences? Everyone is with me?
Yeah, ma'am.
Ma'am.
Okay. All right. So simple one. You have to classify an email as a spam or non-spam email. So if this is a problem statement, any one of you, can someone let me know that what would be the task? Task is, the output which you expect, right? The thing which you wish to do, that is the task. So what would be the task in this case?
To classify emails as spam or not.
Correct. Okay, so this is the copy of that one. Okay, that is true. I will change it. And what would be performance P?
How much were perfectly classified?
Correct. So, how many email has been classified correctly as spam or non-spam emails, right? So, spam emails, does these emails has been classified as spam only. So, how percentage? How much is the percentage, right? Correctly said. And what would be training experience for this? Tell me.
The involvement of like malicious software and all that in the mail, maybe,
Okay.
or
Actually.
the
Mhm.
specific
The
sender who sends these emails as spam, maybe.
number of words which are used to classify the email.
Correct. So the keywords, how, experiences would be the keywords, spam or non-spam. So here, how that classification takes place. So basically, there could be few words that is going to be there. If your name is there, someone is addressing you, that should not be put it in spam, right? How many senders are there? So like this, that would be the experience. So with experience, that should improve, right? Playing checkers game. So here if you see, a task is, like playing the games. Performance measure, percentage of the game won against opposer, that is the performance measure. And experience is like, playing that game against itself, right? So what does it mean, that which particular move would be the best in that given scenario, that is what is the experience. And any type of game, any type of, whether it is chess, checker, tic tac toe, so these task, performance measure, and experience is going to be similar one. Right, fruit prediction problem. So here, a fruits, like, multiple fruits are coming. So task is like, forecasting different type of fruits for recognition purpose, whether this is an apple or this is guava, like this you are going to identify. Then after performance measure is, you need to identify the fruits from the maximum variety, right? So further, if kiwi is coming, so that should be classified correctly as kiwi, right? It should not get confused with any similar looking fruits. So that is the performance measure. Now uh, experience is training a machine with the largest database of fruit images. So experience is like, you need to have largest fruit images in various conditions. It could be lighting situation, it could be different size of apples, right? Even what if apple is not properly ripened, right? Initial stage, how that fruits is looking. So you need to have that database. So many time what happens, that if it is like, about experience, so if any problem is related to game, right? So it would be what would be the next move. Similarly, if it is images based, so you need to understand that if it is image based problem, in that case, the database which we are feeding, and that is what is going to be the experience, right? So if I'm saying that it should improve over the time, so it's important to understand that basically it should have a really nice clean data set and have the maximum variety in that. This is important to understand. Okay, now Just one sec. Yeah, okay, so we were discussing about what is the well post problem. So I was talking about the types of problem, right? So what I said that, if it is like image classification based problem or any object detection problem, right? So for that, it's important to understand that my experience will completely rely on the database which we are using, right? So I want you to answer that what would be the problem, like what would be the task, performance, and experience if a computer program is trying to identify the faces, right? So face recognition problem is the next example, and I want you to identify what would be the task, what would be the performance, and how you are going to measure the performance, and what would be the experience which is going to improve that performance. Anyone can start now.
Tasks would be to correctly classify the faces or to recognize the face.
Okay, all right. Task is to predict different type of faces. Go ahead. Yes,
Performance would be, ma'am, like how much percentage of faces were correctly identified.
correct. So it should be able to predict that faces, right? Different faces. It should not happen that in that database only three persons faces are there. So it's important that your database is wired one and multiple faces are there part of it. And nicely done. Tell me what would be the experience for this.
different images of faces.
Okay.
A
Different,
database.
yes, data sets, right? So data sets which will be having different face images, very correctly said, right? So like this, whatever, I hope you know I have given here multiple statement, and you can go through. There is a nice blog on Geeks on Geeks for this. You can see many experience, but this is something you need to identify before creating any model. So it's important that you just go through these uh, three measures. What would be the task, how we can improve the performance, and what would be the experience which will further improve the performance, right? So it's important to understand that uh, there is always trade-off. We will come to that point also. But the next thing which we are going into this session is designing a learning system, where designing a learning system in machine learning. So let's see this, right? So if you have to design learning system, right? So how you are going to make it? So we have already discussed that basically in machine learning problem, here I'm writing. So if it is an ML problem, and then what we can see that the performance of this ML should improve over the experience, right? So this is going to improve, and this will be with experience E. So it's important that whatever machine algorithms or mathematical model you are generating, right? So that should be able to make that prediction properly, right? And without program explicitly. When I'm saying that without program explicitly means what? We are providing more and more training data, and that is what is the meaning of experience, right? And over this experience, the efficiency, the precision, like this, the various performance matrix parameter should improve. Okay, so here in machine learning, now what we can say, that this is the training data which we are providing, right? And we have to identify appropriate machine learning algorithm here, machine learning algorithm, and then we have to build a model for this application, build a model, and then you have to get that appropriate output. So in this designing process, this is the steps which you can see on the screen, right? So you can take example of self-driving car. There are few examples which are my favorite, that weight versus height, then spam, non-spam, driverless car. So in case of autonomous car, what happens that the training data is fed to the algorithm, like how to drive car on highway, how to drive it in busy road, how to drive it with a narrow street, how to drive when there is a sharp U-turn, right? So like this, there are many factors also. What should be the speed limit in all the above said scenarios? Uh, in highway, obviously speed would be more, but whenever there is a narrow street, in that case speed would be lesser. Then after, an important aspect of self-driving car is how to park it properly, right? How to park it with a very uh, if he somebody is going for shopping, in that case, if it is raining outside, so that self-driving car should be capable enough to leave that person at gate of the mall, and then after coming back in the parking, and that car should be parked properly, right? So like this, what is happening, that the more and more data will be feed to this, the more efficient output will be produced. And that's why it's important to say that this performance P is going to improve over the experience E. And that is the meaning of, how it is going to improve, right? So now coming to the steps, for designing a learning system in machine learning, the very first step is choosing the training data, right? So you need to choose a training experience, right? You need to identify what would be the input of this machine learning algorithm, right? Here, as I told, the very first thing is like, identifying the training data. So you need to you need to find the algorithm, but before that, what data you are going to feed to that algorithm, that should be known to you. And if you want a better training experience for the machines, it's important that you use some sort of direct and indirect feedback. So what could be direct feedback, right? So if you are taking any type of game example, it could be chess playing, right? So what would be training data, what would be the moves? So that would be your experience, right? So here, providing feedback is like, thinking, what if instead of this move, I move the queen itself, right? So like this, it is going to uh, increase the success rate. Second important attribute would be what type of data is feeding to that machine learning, right? So it's important that it should be valid one, variety must be there, right? And then only it is going to improve. The second step here is choosing the target function. So once you know that what will be my input, the second step is to choose the target function. So the target function means what? Once that input data is fed to the algorithm, the next move in the game example, right? If it is game, what would be the next move? So that we can consider as target function. If it is classification problem, what would be the features, right? For that could be the target function, right? What would be my reason of interest, finding ROC in my images? So that would be my target function. So once you have chose your training experience, right, then after you are going to choose the target function, and after that you are going to represent that target function with you are going to do it with some sort of mathematical model, right? You are going to do it with a linear equation. You can do it some sort of graph representation could be there. In some cases, tabular form is also applicable. So it depends what type of target function representation you are using. Are you going to use equation, mathematical equation, any type of equations, or you are going to use graph representation, right? So here, once you have properly represented the target functions, what happens that many times what happens that optimize as we are discussing the game problem, so optimized move is not possible. It's not going to be the best move, right? So what happens that how your opponent is playing, on basis of that, finding that best move is choosing the approximation algorithm, because optimized move is not the one which you are thinking. You are thinking like, I will pick this particular move, and then after opponent may go this way, but opponent has done something differently, right? Opponent move was different from your thinking. In that case, accordingly, approximation algorithm need to be used, and then after there will be the final design. So this is all about designing a learning system in machine learning. Okay. So is there any query here in this topic? Is there any query? Quickly let me know. No. All right. So let's go ahead with next topic. Let's see. Okay, so we are going to quickly discuss now the next topic, which is practical issues in machine learning. Okay, so if you are what would be the practical issues? So the first thing is monitoring and maintenance. I'll come to this point later. Data quality, right? So what would be the data quality? Because the fuel of this machine learning is the data which you are providing, right? So your experience, or what we can say that we have talked about the performance. So this performance relies heavily on experience, right? So here it is important to note down that my machine learning algorithm will perform well if and only if we are giving proper data to it, right? We are considering all the scenarios to make it good machine learning applications, right? So obviously machine learning is having great potentials, right? But there are few challenges also, and these challenges mostly rely on data, right? And the second one could be ability to execute the complex computation. So I hope you remember yesterday we have started our session with for what type of applications human brain is better than machines, right? So we have seen that we are good in learning from experience. That aspect is better in human. So once you are teaching a kid that this is a car, right? So even if you are giving another type of car, so human brain is capable to quickly pick up, okay fine, this is also a car, whether that car is occluded one, or that car you could see it from far distance, right? So all these factor doesn't affect much. Okay, so okay, let's coming back to the practical issues in machine learning, and we were discussing the data quality, right? So any type of machine learning applications relies on data, and it's important that whatever data you are feeding to that system, right, that should not be that should not be biased by sensors values, or that sensor. So what is happening, that if it is IoT application, right, so you are using multiple sensors so for collecting the data. And in the first lecture I told you that why machine learning is popular nowadays. The reason is enormous data is available now, and these data, as we are fitting more data, then obviously my performance will increase. But if sensor itself is getting erroneous data, right, in that case what will happen, my output will be also erroneous, right? So it's important that the data which you are getting should be correct. Okay, or sometimes what happens that prepare a set of questions for customer, right, before applying machine algorithm. So we are talking about questionnaires. What if somebody has not felt it seriously, just for sake of doing it they have done it, right? And if that questionnaire itself is incomplete, it could be incomplete, or some different type of options which you were not expecting is there, right? So better way you can provide different drop down options, right? So like this, mm, quality of data is going to affect the machine learning performance, right? Now coming to the complexity and quality trade-off. So what does it mean? That as I told you, that if you are talking about attendance monitoring system using machine learning, using face recognition, right, and you are feeding just 5 persons data there, then there's a very high chance that it will detect it properly. How it is behaving with 80 students images, how it is behaving when somebody is quite far, and then how images are whether that image is able to be processed for their attendance or not. What if somebody is not exactly facing towards camera, side view is that machine learning algorithm is able to identify that side view or not, right? So it completely depends upon the complexity and quality trade off. So if your ML algorithm is complex, right? So in that case, what will happen, that obviously the quality of that ML algorithm would be more, means what, the precision would be more, accuracy would be more, so performance would be better. But to make identify in different scenario, that ML is going to be complex, right? Machine learning algo is going to be complex when you need to consider various things, right? So this is the trade off, and you need to understand it properly. So as I told you that faster, if you want to make a machine learning algorithm work faster, it means what, various aspect you might not have considered. But if a machine learning is having slower response, but if it is giving more accurate result from the model, right? This is what you need to find, what is your priority, whether you want faster output or you want accurate output. And that is what is the trade-off between complexity and your this one. So now coming to the monitoring and maintenance. So what happens that say that spam detection, you have made this machine learning algorithm in 2010. At that time, you know the category of spam and non-spam mail, non-spam mail. Now what happened after 11 years, the definition itself got changed. There could be various category where earlier days those mail might not be considered as spam mail, but now various type, there are different ways to send the mail so that it is doesn't come under a spam category, though Gmail is having their own way of categorizing a spam or non-spam. But I discussed in the previous session also that personalized spam filter can be used, where somebody is uh, doing it as per their requirement, as per their need. Because it may happen that for someone this mail might not be spam, and for you it can come as spam filtering, right? So here monitoring and maintenance is something, it is not going to happen that you have made one machine learning algorithm or model and that will work even 5 years, right? So it's important that you you need to add features, right? You need to add features, you need to continuously train that model for the self improvement of that model, right? So the model may require some different type of labels also later, so that results can be properly uh, improve, right? So this is what you need to understand. Then after, what is remaining? Okay, sampling bias in the data. This is something you can consider one example of say okay say that classification or finding appropriate resume for a post, that is the data, right? And we are applying machine learning algorithm uh, to assist this recruitment process. Okay. And nowadays many companies especially Amazon, there was one article which has came 2 years back, that Amazon discovered an algorithm which can assist selecting the candidates. Okay, so what can happen that bias could be introduced in data by that sometimes it could be questionnaire, which we have talked about. Else what can happen that I am writing my resume and I can say that okay fine, I know this one also, I know DBMS, I know data structure, I have worked on so and so project, I am writing that I know machine learning. though I don't know machine learning completely, I have just done one project, and I'm putting there machine learning, right? So that is something is, sampling bias in data, right? So it's this is very challenging thing, right? Because what happens that we are going to apply that we are going to feed data to that model, right? But what if that data is bias one, right? And it's important to understand that bias. And this the fifth point which is mentioned here, that changing expectations and concept of drift, which is pretty much related with its previous point, right? What happens that machine learning, as I told, it should work in different type of scenarios, okay? And especially if you are dealing with some recommendation engine, so in some cases it may not harm. So if it is just, on Netflix, if a recommendation is coming, right? Or a second thing could be, if a customer if, for example, some products which is coming on Amazon, right? So both are recommendation image uh, system. Basically you are using some recommendation system, Netflix. So there, at Netflix it may not harm, but when some other type of product suggestion is coming, and their rating is also very nice, but that product might not be good, okay? Because the rating is only for 5 people, and those 5 people have given rating 4.5 or something like 4.8, right? So all these things we can relate it with the concept of drift. So these are the various type of practical issues in machine learning. So it's important that whenever you are designing a machine learning model, you considered all these points. Okay, so I'm ready to take up your questions. If you are having any, let me know. Any queries, any question? No, I can't see any question in chat box. Please